Okay, so let's continue our discussion on operations involving propositions. For the next operation, we discuss disjunction. And the first type of disjunction that we will discuss is inclusive OR. The inclusive OR of propositions P and Q is described as follows. The word OR is attached to form the disjunction of propositions P and Q. In symbols, we denote this by this symbol. We have P, inverted V, and then Q. We read this symbol as P or Q. Aside from the word or, we can also use the word unless. Now let's describe the truth values of the disjunction. The disjunction P or Q is false only when both P and Q are simultaneously false. We can better describe this using the truth table. The truth table of the disjunction P or Q is shown below. So as you notice, if P is false and Q is false, the disjunction P or Q is false. On the other hand, if P is false but Q is true, then the disjunction is true. If P is true and Q is false, we see that the disjunction is still true. Finally, if P is true and Q is true, the disjunction is also true. Now let's describe or give examples on how to state the disjunction of propositions. For our first example, let P be the proposition Carla is studying. Q is the proposition Carla is at the library. Then the disjunction can be stated as Carla is studying or at the library or both. Now notice here that the extra phrase or both is stressed so that to allow the possibility that the two propositions can be true simultaneously. For our next example, we have R, the proposition Rob eats 3 times a day, and S is the proposition he is on a diet. Then the disjunction is Rob eats 3 times a day unless he is on a diet. Now, can you give a situation where Rob is both eating 3 times a day and on a diet? I'd like to see your comments below. Okay, for the next type of disjunction, we have the exclusive OR. The exclusive OR of propositions P and Q is described as follows. If the disjunction of P and Q is exclusive, we write this in symbols as this one. In computer science or discrete math, this symbol is read as P XOR Q. Now let's describe the truth values of the XOR. The disjunction P XOR Q is true only when exactly one of P and Q is true. Now this can be better described using the truth table. The truth values of the disjunction P, X, or Q is shown below. If P is false and Q is false, the XOR is also false. If P is false and Q is true, the XOR is true, as we have mentioned earlier. Exactly one of them is true. If P is true and Q is false, the XOR is true. Finally, if P is true and Q is true, the XOR is false. Now let's have examples on how to state the XOR of propositions. For our first example, we have the proposition P, presidential candidate A wins the election. The proposition Q, presidential candidate B wins the election. So for the exclusive OR, either presidential candidate A or B wins the election. So as you notice, candidate A and candidate B cannot win the election simultaneously. Unless, of course, candidate A is the same as candidate B. For our next example, the proposition R is Matilda is at school. The proposition S is Matilda is at home. The disjunction is either Matilda is at school or at home. So notice that the statement Matilda is at school and Matilda is at home cannot be simultaneously true. Unless, of course, Matilda's school is also her home. This ends the discussion on disjunctions.